Good afternoon all. Is my slide visible to all?
Yes.
So previous session we saw some thermodynamic property and their relationship with each other with the help of Maxwell equation and the mnemonic diagram. So today we will see the equation of the states. So there are the equation of state like AP is equal to function of pressure, temperature and volumes. So this is a simple state to for applicable for the ideal gases. And one either the PV is equal to nRT. So this is valid at low pressure and high temperature. But at the for other gases or other condition like high pressure and low temperatures, and means at any temperature and pressures. So ideal gas is not applicable. So there are some other equation of state which explain or study the real gases. So equation of state for the real gases. So here ideal gas is inadvocate to explain the behavior of the real gases, and the real gases to behave adequately, the molecular interaction should be negligibly small, and also volume of molecule is negligibly small compared to the total volume of the gas. Right. So here start the first equation of state for the real gases, van der Waals equation. So here is the equation P plus A divided by V square into V minus B is equal to RT. Here A and B are called the van der Waals constant, and this equation is a cubic in volume and below critical temperature. There are the three roots. The largest is vapor, smallest smallest is the liquid, and intermediate is a not as so non means intermediate root has no physical significance, right? uh, the constant in the van der Waals equation can be evaluated utilizing the limiting conditions to be obeyed by any equation of the state. The applying this criteria in above equation, so we get Vc is equal to 3b, Tc is equal to 80 into T7 Rb, Pc is equal to Rtc divided by 2b minus a 9b. Here Vc is a Tc is a critical temperature. So similarly Pc is a critical pressures. So critical temperature means it is the highest temperature at which the substance can exist as a liquid. So when the temperature is less than critical temperature, it's called the vapors, and when the temperature is greater than the critical temperature, it's called the gas. So this is the constant based on this terms. This is the van der Waals constant. A is equal to this one, so 27 into R square into T square, or divided by 64 Pc, and B is equal to R into Tc divided by 8 into Pc, right? So based on the van der Waals equation, so here are the questions. The parameter A and B in the van der Waals and other cubic equation of state represent. Anyone guess the significance significance of van der Waals constant A and B. That is what does it indicates. So here A indicate the molecular attraction and B the molecular size. Now question 2, a container has a O2 at 5 atm and molar volume 2 liter per mole. If A is equal to 9.24 atm into liter per mole and B is equal to 0.0907 liter per mole, what is the temperature of O2? Use the van der Waals equations. All of it try to solve using van der Waals equations. So P plus A V square V minus V is equal to RT, right? So I have to calculate R. So all the given. So first convert this equation T is equal to P right R. Now put the value here and solve. Into volume 2 minus B constant 0.0907. So here R is a 0.0821 liter atm per mole per Kelvin. It to 0. Right. $170 Kelvin. All of you got this one?
Yes, sir.
Okay, good. Now question 3, the work done by 1 mole of van der Waals fluid undergoing a reversible isothermal expansion. Right. So from initial volume Vi to the final volume Vf. So have to calculate the work done. So work done on the gas is given by the work done on the gas is equal to minus PdV. Now work done by the gas on the surrounding, W is equal to P dV, right? Now we know the van der Waals equation, P plus V square V minus V is equal to RT. Now put the value P is equal to RT V minus V A V square. Now put this value in these expressions and integrate from initial value to the final values. Vi Vf. So RT V minus V into A by V square dV. So here A ln V A minus B Vi minus V initial here plus A 1 by Vf minus 1 by Va. It's a simple one. Question for 1 kilo mole of CO2 occupy a value 0.381 meter cube at 313 Kelvin. Compare the pressure given by the ideal gas equation and van der Waals equations. Take the van der Waals constant to be A is equal to this value and B this one. First we calculate ideal gas equation. So we have to calculate PV RT V. .314 into temperature 313 and 0.381, right. So here is the mention 1 kilo. I'll just check the unit. Joule, kilojoule, kilomole into Kelvin. Kilomole get cancel into Kelvin get cancel. Here is a meter cube, right. Now multiply 10 to the power 3, so joules, Newton into meter square, right. So how much? 68.30 into 10 to the power 5 Newton per meter square, right. So convert into the bar, it's a 68.30 bar, right. So 1 ATM is equal to 1.01325 bar is equal to 1.01325 into 10 to the power 5 Pascal or Newton per meter square. This is a conversion, which is equal to 760 mm Hg, right. Right. Now B part. So van der Waals equations. So P equal to RT divided by V minus V equal to A V square, right. Put all the value here. 8.314 into 313 to V. So initially convert the this volume into molar volume. So 0.3, here is a 1 mole, 1 kilomole, 0.381, so meter cube per kilomole. Now put this value in this. This is the molar value. .381 into 10 raised to the power minus 3 and B point into 10 raised to the power minus 5. A given 0.365 and V square, so 0.381. Sorry, here is a molar value, so here 381 into 10 raised to the power minus 3. So 51.8 10 raised to the power 5 Newton per meter square is 51.8 bar. All of you got this value. The pressure for the ideal gas is 68.30 bar, and for van der Waal 51.8 bar. Yes.
Yes, sir.
Okay. Now other equation of state, Redlich-Koch equation. Here is the equation PV is equal to RT V minus V into A T raised to the power 5 into V plus B. This is the constants of these equations. Then Redlich-Koch equation. Here PV is equal to RT V minus B minus A dash T divided by V into V plus B. Here A dash with the temperature which is equal to A into alpha. So here alpha is the function of temperature and eccentric factors. In Penn-Rabinson equations, here this one, the P is equal to RT divided by V minus V minus A into alpha divided by V into V plus B into V minus B. So here alpha is a function of reduced temperature and eccentric factor. The question by which of the following is not a equation of state? Can someone tell the answer? This is the equation of state. UO, yes. This is also UOS. This is Charles equation. P is direct proportional to V. This is not a equation of state. Now Holborn equations we will say on next topic. So answer is B. Now virial equation, the ratio of volume of real gas to the volume of ideal gas RTP is called the compressibility factor. Z is equal to P divided by RT. So which is equal to plus 1 plus B dash plus P into C dash plus P square into D dash P cube. So here and for this is truncate equation, Z is equal to PV divided by RT equal to 1 plus B divided by V into C divided by V square plus D divided by V. So here BCD and B dash, C dash and D are the virial coefficients, and B and B dash are the second virial coefficient. Similarly C and C dash are third virial coefficients. Now this coefficient are the function of the temperature only, and this variable equation applicable at low to moderate pressures. Here is a constant value of this, means coefficient value of the variable equations. So this one is a Holborn-Otta equation. This one. This is a Holborn. Holborn Otta equation. So based on the variable equations, so we will some problems. So variable equation is a option are the arithmetic progression, geometric progression, harmonic progression, none of them I mentioned. So here PV is equal to RT 1 plus B by V plus C by V square plus D by V cube, right? So for to check arithmetic progression, the for the n term, the one equation like this is AP A1 plus n minus 1, D is the difference, A is the initial terms, N is the numbers. And for GP, for the n terms, so an is equal to a1 initial terms, but r, this is the ratio per means final divided by 12 second initials in minus 1, right? Like 2 and 4, the r is 4 by 2, this is r is equal to 2, right? And for harmonic progression, it is equal to 1 divided by AP, arithmetic progressions expression, like A1 plus n minus 1 D, right? This is the 8P. So here so this is not a arithmetic progression, so it's a geometric progression. How? Suppose we check for the geometric progressions. So suppose for one terms, so for take a n is equal to 1, so a1 initially 1, r is a here r is just suppose 1 by v, so initially 1, right? So this is a 1. Now take a n is equal to 2, right? One, so this is a 1 by v. Similarly, here is equal to 3, 1 by v 2, right? So I can write down v square. So you can write down the n terms. So this is the geometric progressions. All of you got understood?
Yes, sir.
Now question 7, which of the following is true for the virial equation of the states? The option are virial coefficient or a universal constant. This is the wrong one. The virial coefficient be represent the three body interaction. No. The virial coefficient are the function of the temperatures. So this is solutions of question 7. And these for some gases virial equation and ideal gas equation are the same? No. Question 8, the boil temperature is the temperature for which here limit p tends to 0 dz by dp at constant temperature is equal to 0 at a boil temperature. The boil temperature a temperature at which a real gas obey the ideal gas law over the appreciable range of pressure is called the boil temperature. Right. The option are the second virial coefficient be 0, the third virial coefficient C 0, and the second virial coefficient B is unity, and third option D is the third virial coefficient C is unity. So can someone try to solve? How would we solve this? So this is a based on the virial equation of states. So Z, this is a compressibility factor 1. Here is a mention P, so we can write plus B dash P plus C dash P square plus D dash PQ, right? Now differentiate with the temperature dz by dp, the constant temperature, B plus twice Cp and 3 d dash pq, right? Now take a limit from p tends to the 0, limit is equal to B, right? So here now here is a given limit p tends to 0 into dz by dp at constant temperature is equal to 0. So B is equal to 0. And this is a second virial coefficients. So here B is equal to 0. So in the option given the second virial coefficient B is 0. So answer of question 8 is a A, right? All of you got clear?
Yes, sir.
Question 9. Using the virial equation, calculate the molar volume and compressibility factor of isopropanol vapor at 473 Kelvin and 10 bar. The virial coefficient are B is equal to B and C value are given. So I have to calculate molar value and compressibility factors using virial equation. The virial equation was in a truncate forms, Z is equal to PV B 1 plus C by V, right. So to calculate the molar volume, V is equal to RT by PA into 1 plus B divided by V plus C divided by V square, right. To solve this expression, first we calculate the volume for the ideal based on the ideal gas. V is equal to RT by P. So 8.314 into 473 divided by 10 into 10 to the power 5 Newton meter square is equal to 3.93 into 10 to the power minus 3 meter cube mole, right. This is the equation. Now put this value V put this value in the right of these equations, then we get a V value. When we evaluate both are same, that's the molar value. Like suppose put here and then you will get the difference. If you not get, then puts once again in the right side of this equation. When V equal, that's the molar value. So is equal to, after iterations, we get 3.485 10 to the power 3 meter cube mole, right. Now similarly, G is equal to PV, this complexity by 8861. All of you getting or not?
Yes, sir.
Means this value means we calculate the value by ideal gas. Put this right side of this equation. It should be equal. Do the iteration till both the term with both the side value means both the side should be equals. Now question number 10. The value of compressibility factor at the critical point evaluated using the van der Waal equation of the state is. So we know the compressibility factor Z is equal to PV by RT, but here asked at a critical point. So PC VC divided by RTC. So we know the VC is equal to 3B, TC is equal to 8 by 27 BR, right, and PC equal to 1 by 27 A B square, right. Now put this expression in this equation. So here PC 1 by 27 A B square to BC 3B R TC 8 by 27 B into R into A. So R 8 get cancels. B square cancels, A get cancels. So 27 it cancels. So 3 by 8, right. I hope all of you got clear. Now question number 11, the parameter in two parameter theorem of corresponding state are. The option are reduced temperature and reduced pressures, then compressibility factor and asymptotic factors, reduced temperature and asymptotic factor, reduced pressure and compressibility factor. Right. So Z is equal to function of TR and PR. So solution of question number 11 is a reduced temperature and pressures. And the generalized compressibility chart give the value of compressibility factor Z as a function. So TR means the reduced temperature. So it is a temperature away from the critical temperatures. So T divided by TC. So it is a function of reduced temperature and reduced pressure. So answer of question 12 is a B, right. This is a TR, this is a PR, right. Question 13. The volumetric property of two gases M and are described by generalized compressibility chart, which express the compressibility factor Z as a function of reduced pressure and reduced temperature only. The operating pressure P and temperature of two gases M and R along with their critical properties PC and TC are given the tables. This is the tables with the value of properties. So here Z M and Z N are the compressibility factor of the gas M and N under the given operating conditions expected. The relation between Z M Z N. Okay, so we have to calculate the compressibility factor for M and N gas, right. So as we know, or here also mentioned, the compressibility factor Z is equal to a function of reduced temperature and pressure, right. So here given the temperature and critical pressure and temperature, so we have to calculate the reduced temperature and reduced pressures. So here TR and PR, right? So TR for farmer, to calculate TR, T by TC. 1 minute. So TR T by TC and PR P by PC. 300 150 is a 2 right. For PR P 25 divided by 75, 0.33. This is 0.33, right? So almost same reduced temperature for M and N gas, and similarly for reduced pressures. So here Zm is equal to Zn, right? All of you get clear or not? Yes, someone? Question number 14, the parameter in the 3 parameter theorem of corresponding state are, the option are given: reduced temperature, reduced pressure and reduced volume, then compressibility factor, asymptotic factor and reduced volume, reduced temperature, reduced pressure and compressibility factor. T is a reduced temperature, reduced pressure and asymptotic factors. So for the 3 parameter theorem, generally state are the reduced temperature, reduced pressure and asymptotic factors. Question 15, the asymptotic factor omega is defined by, as all of you studied already. So omega is equal to -1 log to the base 10 reduce pressure set at TR 0.7, right? So option B. The question 16, the asymptotic factor bar the simple fluid is equal to the, can someone tell the answer?
Zero point 0.7.
No, wrong. Generally for the simple fluid like argon, neon, krypton, omega means acidic factor is 0. Now for a complex fluid, it greater than, this is omega greater than 0 for a complex fluid. Please note down all of you. Question number 17. The acidic factor of water is reported to be 0.345. For water, the difference log PR sat argon minus log PR sat water is evaluated the reduced temperature of 0.7 is equal to. Can someone solve and tell the answer? How would we solve this? Here is a given the acidic factor of water is this one. So this is the omega given. And difference here for argon and waters at reduced temperature 0.7 which is equal to. Here is the argon simple fluid. So we know the acidic factor minus 1 log T PR sat at TR is equal to 0.7, right? So for argon is a simple fluid. So omega is a 0, means acidic factor 0. So it's a 0, right? So log T PR sat at TR 0.7 is equal to -1, right? Now here mention that log PR sat argon, this is for the argon, log PR sat for water, here is you mention water at TR, right, 0.7. Here is the ask the difference. So we calculate for these terms -1. So write down -1. And for water, so put these terms. So -1 minus omega, right? So which is equal to -1 plus 1 plus omega. Get. So finally the omega. Here is a mention. Here is a reported that acidic factor is for water 0.3045. So difference is all of you got clear?
Yes, sir.
Okay. So I covered all the questions based on the equation of state, like van der Waals equation and others, then virial equations, and then compressibility factors, and then corresponding principles. So if you have any doubt, please ask. If you don't have any doubt, I'm concluding today's sessions. So thank you all. So we will meet on next Saturday on next chapters.
Thank you, sir.